Hello everyone, I'm Naresh, a DevOps and SRE solutions architect. Welcome to this brand new video series on common system design concepts. In this series, we'll tackle real-world system design challenges and bring them to life using practical solutions and real cloud services. Whether you're preparing for interviews or building scalable applications, this series is designed to give you hands-on experience with the tools and architectures that power modern systems. In today's video, we're kicking things off by building a URL shortener service, like bit.ly or tinyurl. We will go through the outline of what to expect from this series. We will begin by understanding the problem statement, followed by a requirement analysis, and then walk through a clear architecture diagram to set the foundation. We will also define the goals of the system and discuss any limitations we need to be aware of. From there, we'll move into the implementation phase, which is split into two parts. In part 1, we will focus on setting up the core components, that is, DynamoDB, AWS Lambda, and configuring the right IAM roles and permissions. In part 2, we will expand the system with API Gateway, CloudFront for content delivery, configure DNS settings, and run load testing to evaluate performance. Whether you're new to system design or looking to deepen your cloud architecture skills, this series will guide you step by step through building a scalable serverless solution on AWS. We will now take a look at the problem statement. The requirements of this service would be to have high availability, have low response times, serve hundreds of thousands of customers simultaneously, scale gracefully, yet be cost-effective. We will now list the primary users of the URL shortener service. The first actor is the service provider, which is you, who would host and maintain this service. The second actor is your customer, who would be individuals or organizations who use your service to shorten their website's URLs to share with their customers. The third actor is the end user. End users are your customers' customers. They click on the shortened URL that you provide to be in turn redirected to the original URL. Now we shall analyze the requirements in detail. First, let's look at the Shortener API. The Shortener API will take in a URL and generate an hexadecimal hash, which will be an alias to the original URL. It will be called only once when a URL is to be shortened by the customer. The map of the original URL and the hash has to be stored in a database. The response of this API, in other words, the shortened URL, will be shared by your customer with the end users. Next, let's analyze requirements of the redirection API. The redirection API, as the name suggests, will handle the redirection itself. It will take a hash alias and look it up in the database. This URL will be called by thousands of end users simultaneously, and they would also be distributed across the world in various countries. Let us now explore the high-level architecture of this implementation, moving left to right and top to bottom. First, the customer would call the Shortener API along with the original URL. The request would be received by the API gateway and in turn forwarded to the Shortener Lambda function. The Lambda function would generate the hash alias, store it along with the original URL in DynamoDB, and then return the shortened URL to the customer. The customer then shares the shortened URL with the end users, usually over social media or text messages. The end users, who are usually large in number, click on the shortened URL. This request will be received first by CloudFront, which is a content delivery network, or CDN for short. CloudFront forwards the request to the API gateway, which in turn forwards it to the redirection Lambda function. The Lambda looks up the DynamoDB table using the hash alias and redirects the end user to the original URL using a temporary or permanent redirection using HTTP. CloudFront then caches the redirection response. Let us now understand the goals and limitations of this implementation. First, the goals. How to configure DynamoDB, Lambda, API Gateway, DNS, and CloudFront to the extent needed to implement a working model of a URL shortener service. We will also load test the model to assess its capabilities in the end. Next, let's take a look at the limitations. Security hardening of the service, including but not limited to API rate limiting, vulnerability assessments, penetration testing, firewall configuration, protection against DDoS, SQL injection attacks are not included in this video series. In other words, this implementation is not production ready. You will need to improve it to suit your organization's needs. With this, let us now head over to the exciting and fun part of implementing the URL shortener on AWS. First, we will begin by creating a DynamoDB table in the same region where the Lambda function will be deployed. The table will be named redirect map and will use hash as the partition key. The table settings will be customized with the class set to DynamoDB standard. For capacity settings, the read consistency will be changed to strongly consistent and the read-write capacity mode will be set to on-demand. The warm throughput settings will be left at their default values. There will be no secondary index configured for this table. DynamoDB default encryption will be used and delete protection will be enabled. The resource-based policy will remain empty and adding tags is optional. We will now create the Lambda functions that will handle URL shortening and URL redirection APIs. Here is how to set them up. First, select the option Author from scratch. Next, name the function HYD-shortener for the shortener API. HYD here indicates the region Hyderabad where the function is created. The function will use Python 3.13 as the runtime. We will use the x86-64 architecture. You can use ARM architecture if you prefer. Any architecture would be fine if you are going to edit the code in Lambda's editor. But if you are uploading the code, the architecture must be the same as the system where you create the zip package. Next, a new Lambda execution role will be created for the function. All additional configurations will be set to their default values. To add the function code, follow the link to the code in GitHub provided in the description below. Now, repeat the same steps to create the HYD redirect function. Everything remains the same except for the function's name. We will now add the necessary IAM permissions to the Lambda function's roles for accessing the DynamoDB table. First, we will add permissions for the shortener Lambda function. Click on the shortener Lambda, then click on the Configuration tab. Then click on the Permissions link in the navigation bar to the left. Then click on the IAM role assigned. In the Permissions Policies section, we can see that one policy was automatically added by Lambda when it created the role. This policy is for storing logs on CloudWatch. On the right, click on Add Permissions button, then click on Create Inline Policy. In this screen, Select DynamoDB service, then add the put item permission. Under the resources section, select specific, then add the ARN of the DynamoDB table that was created earlier. Finally, add a name for the inline policy and click on Create Policy. Next, repeat the same steps for the redirection lambda role. In this case, add the get item permission and restrict it only to the redirect map DynamoDB table. This concludes part 1 of implementing a URL shortener service using serverless tools on AWS. We have created a DynamoDB table, 2 Lambda functions and their corresponding IAM roles. In part 2 of the series, we will explore how to configure API Gateway, DNS, SSL and CloudFront. Also, we will load test our implementation to evaluate its performance. Thanks for watching.